Welcome to another video. In this video, we will be taking up the topic electric vehicle motor or EV motors. We will be looking into the construction, the basic construction of these motors and how they function. And then we will also discuss about the different types of electric motors that are most commonly used in modern electric vehicles. And then also we will be looking into the advantages and disadvantages of each of these types so that you can have a comprehensive study or idea about what are the pros and cons of all these different types and which one is used at which place or at which scenarios. Okay, so let's start with this course. Okay, so in this course we will be looking at the introduction. We will start off with an introduction, and then we will talk about the brushed DC motor, which is the most basic form of a motor to get you started with the basic working of a motor. And then the induction motor, which is the most commonly used electric vehicle motor. And then next is the permanent magnet motor, and finally the synchronous reluctance motor. Okay, so let's start off with the introduction. Now, what is an electric motor? A dictionary describes a motor as a machine that converts electrical energy to mechanical energy. So basically, you supply electric current to this motor or electric motor, and in return, it will give you rotary motion as output. This conversion of electricity into mechanical force or motion takes place through the interaction of magnetic field and current carrying conductors. One of the component of motor rotates due to this interaction. We call it the rotor, that is this one at the center. And then we have the stationary component, and because it is stationary we call it the stator. It will be clear once we get into the working part later in this topic. These electric motors are vastly superior to gasoline and diesel engines. They are much lighter and cheaper. They need no maintenance, and most importantly, electric motors are 3 times more efficient than a combustion engine. I mean, just look at this IC engine with all these thousands of components and complex parts all meshed together. All of this is just to extract the energy from a fossil fuel. All of these moving components, burning of fuel, friction between these moving parts. You can imagine the amount of energy being wasted in the form of heat, sound, and vibrations. And then we have the electric motor with its minimal moving part. In fact, it only has a couple of essential parts. Like only this part, that is the rotor, is the only moving part that rotates. Nothing else. And it is as simple, just this outer casing and all that, as compared to this IC engine. So no heavy and complex mechanism, and also a very silent operation. That is why they need no maintenance and have low manufacturing, and you can forget about the regular oil change like you do in your normal or conventional vehicles. We have discussed about the internal combustion engines already in this course, how they burn the fuel, which causes the explosion and pushes the piston down to rotate the crankshaft. So basically, an internal combustion engine can rotate only at some fixed RPMs. That also depends upon the amount of throttle that you are pulling. But we need torque to move the vehicle from standstill, and when when high speed are reached, we need more RPMs to drive the vehicle smoothly at high speeds. For this purpose, we use this massive gearbox that you're seeing here. So this is basically the gearbox where the gear reduction takes place. Okay, so this massive gearbox is required because the engine only runs at a few specific RPM, depending on how much throttle that you are giving it. This gearbox contains a set of multiple gears all meshed together. That is why you need to change gears depending on the speed of the vehicle. But our electric motor does not need this massive heavy gearbox. For electric motors, the work of this gearbox can be done by a simple electric controller which alter the electric current and its frequency that is being supplied to the motor to increase or decrease the RPM and the torque. Now, electric engineers have dozens of ways to classify the motor, which can be utterly confusing. Mechanical engineers look at properties like size, weight, and maximum torque. Practical builders look at the things like availability, simplicity, and robustness. Economists and businessmen, people which could be interested in purchase price and the efficiency. And finally, people interested in the environment are often interested in the use of sacred earth metals and the efficiency that it pertains to CO2 emissions. So, getting down to the basics, electric motors can be broadly classified on the basis of the type of current they use. The ones that use AC or alternating current are AC motors, and the ones that use DC or direct current are called DC motors. These AC and DC motors can be classified into dozens of different types. So let's have a look. So we have electric motors, and it can be classified into alternating current motor or AC motor and direct current motor or DC motor. Furthermore, talking about these AC motors, they can be classified into linear motor, which is an electric motor that has had its stator and rotor unrolled. Thus, instead of producing torque in rotation, it produces a linear force along its length. Then we have the synchronous motor, in which at steady state the rotation of the shaft is synchronized with the frequency of the supply current. The rotation period is exactly equal to the integral number of AC cycles. These are further classified into synchronous reluctance motors and hysteresis motors. Then we have the very famous induction motor, which works on the principle of induction of currents, and it can be single phase or three phase. Phase simply means the distribution of the load. Like if the current is supplied in two wires, it is single phase, and if it is supplied in 3 or 4 wires, like a 3-pin connector that or socket we have at our house, we call it a three phase. Now coming to the DC motor type, they can be self-excited, and which can be further classified into series, compound, and shunt types, with two types of compound, that is short shunt compound motor and long shunt compound motors. Okay, now covering all the motors and angles is impossible, and also it is not important with the perspective of electric vehicles. We will discuss on three types of the electric motors which are used in almost all electric vehicles, and that is induction motor, permanent magnet motor, and synchronous reluctance motor. So these three are the most commonly used vehicle motors which are used in almost all of the electric vehicles. But before discussing these motors which are used in electric vehicles, let us have a look at a very basic motor, that is the brushed DC motor. We will look into the construction and working of this one to have a proper solid foundation, because this is where it all started. Okay, so this is the motor that you might have learned about in your high schools. So again, it is a very simple and basic motor and will help you develop a basic understanding of electric motors. A brushed DC electric motor is an internally commutated electric motor which is designed to be run from a direct current power source. That is why it is called a DC brushed motor. Now a commutator is a device which is used to reverse the polarity of the direct current, because direct current does not change polarity, and we will discuss about this even further. So DC motors were the first form of motor widely used, as they could be powered from the existing direct current lighting power distribution system. A DC motor's speed can be controlled over a wide range using either a variable supply voltage or by changing the strength of the current in its field windings. Small DC motors are used in tools, toys, and applications or other appliances. The universal motor can be used for portable power tools and appliances. Then we have the very large and heavy DC brushed motors that are currently being used in a propulsion of electric vehicles or elevators and hoists and in drives for the steel rolling mills. But now these brushed DC motors are not used in electric vehicles. Okay, so how does it work? So like I said before, an electric motor functions by the interaction of magnetic field and electric current in conducting components. So this motor uses a combination of a permanent magnet for the magnetic field and electric coils for the conductors of the conducting components. As you can see in the image on the right, the permanent magnets are fixed on the outer casing with opposite poles on each side. So these permanent magnets creates a permanent magnetic field in the motor, and these magnets on the casing are fixed, and the fixed part of the motor is called a stator. So this is the stator. Now at the center we have this coil or winding of electrically conductive wires, which is mostly copper wire. You basically have a copper wire and you wind it as shown in the form of a loop like this, and we call it the armature only in case of a DC brushed motor. But for the other types of motors, the term armature is a collective term for rotor, the iron core, and the windings. Okay, so coming back to brushed DC motors. Now, how do you supply current to a part that is being rotating like this? So how do you supply a current to this part, the armature, because it will rotate? So we use brushes or carbon brushes for the purpose. These brushes are made up of graphite and they conduct DC current to the armature or the wire winding through mechanical contact. Now from the stator we have a permanent magnetic field which is like always there, and there is a close relationship between electric current and the magnetic field, and that is whenever we pass an electric current, whether it be AC or DC, through a wire winding or coil, it will create a temporary magnetic field of its own. And we also know that the same poles of a magnet or a magnetic field repel each other and the opposite poles attract each other. So the permanent magnetic field causes the copper winding or the armature, in this case, starts to rotate when current is being passed through the coil. So when we pass the current through the coil, it creates its own magnetic field that is temporary until the current is being allowed or the circuit is closed. And then we have the permanent magnetic field of the magnets from the stator outside. Okay, so that causes an imbalance. Now the armature or the rotor wants to align its magnetic field with the permanent magnetic field of the stator or the permanent magnets on the outside. So when the north pole of the coil is aligned with the south pole of the permanent magnet, it would stop rotating. Like when the north and the south are aligned of the stator and the rotor, why would it want to rotate? Because the north of the rotor, that is like this one, in this case you can see this is the north of the rotor, okay, this is the south of the rotor, and this is the north pole of the stator. So in this position, why would the rotor want to move? Because they both attract each other. Okay, so we only get half a revolution of the armature in this case. This is where the commutator comes into play. Now, we know that the DC current is non-alternating. The positive remains positive and negative remains negative. So a commutator switches the polarity of this direct current, causing the polarity of the temporary magnetic field in the stator, or sorry, in the rotor, to reverse. Now the north becomes south and the south becomes north, and the rotor will move again to align the north and the south poles with the opposite poles of the permanent magnetic field. And this reversing of poles keeps on repeating due to the commutator, and the armature will continue to rotate until the current is supplied, and the speed can be increased or decreased by changing the frequency of supplied DC current. Now the major drawback of these DC motor is that because the brushes make physical contact with the rotating shaft, they wear out with time and often causes sparks within the motor, and they can malfunction. So they need to be replaced from time to time. They also need a starting mechanism to avoid burning out, and this is why they are not used in electric vehicle. Plus, this motor is quite primitive to be used in modern days electric vehicles. So now, since you know the basics, we will move on with the three types of the motors that are mostly used in every electric vehicle